Hey everybody, how's it going? Welcome back to the channel. My name is Kevin. This is Peznauts. If you don't know who we are, well, I just told you. And if you do, well, I'm sorry about that. I just wanted to make this update video because we haven't done one of these things in a long time. And I wanted to do a little quick project update to show where Director D is in terms of availability and scale. One of the last videos that we did was deploying in a production environment using the Bootstrap command. And I feel like we need to cover what it looks like to scale Director D to lots of clients. So in this video, we're going to use a handful of virtual machines, a whole bunch of containers, and Director D to execute lots of tasks across a huge environment and see what the scale looks like in a production similar environment. So buckle in. It's about to get nerdy, I guess. So the very first thing that we're going to do is actually provision our virtual machines. So let's jump over into our terminal and get that going. Here we are. I'm going to SSH over into my server, escalate my privileges, list out my virtual machines, and we can see that I've got 5 virtual machines that have been spun up for some previous testing. I'm going to clean those up. The new virtual machines, I'm going to build 4 of that are going to be high memory and high CPU counts so that it'll support the 25 containers that we're going to run per machine. So let's do that now. Goodbye, virtual machines. We can list them out. They're gone. Let's create them. Like I said, we're going to do 4 virtual machines. They're going to be running the latest CentOS 8 stream. Each virtual machine will have 16 gigs of RAM and 8 cores. Yeah, that should be enough. Now we'll let that happen. All right, so our virtual machines are online and ready to go. Take a look at our list. We can see I've got Director D 0 through 4. All right, so our virtual machines are online. Let's go ahead and take a look at those. Ta-da! 0 through 4. Now 0 is going to be our server, and 1 through 4, we're going to run 25 containers per virtual machine. That'll give us a scale test of 100 clients. So let's do that. Well, trust in the process. Beautiful. This is Director D0, which will be our server. The server will bootstrap the rest of the environment, provision the containers, and build out the cluster, which again is going to be 100 clients, 100 container clients. So let's get that started. We're going to first install our package dependencies. More sudo. Now we're going to clone our source code. Now that the source code is cloned, we're going to run the dev setup script. More sudo. This is going to install Director D. It's going to put it in a virtual environment and put it under opt. Pretty simple. All right, Director D is installed, so let's go ahead and start the service units. We'll just copy and paste exactly what it tells us, right? It's got a little command, it got a little help. We'll go ahead and add ourselves into the group. More sudo. And now we'll reload the daemon and start the service. More sudo. Ta-da! It's online. Good to go. Now that everything is installed, let's go ahead and create a Bootstrap catalog for our cluster. So the first stanza is our server. The second stanza are our clients. Now we'll go ahead and run the Bootstrap command. As you can see, it's got some help information. So the first thing that we're going to do is pass in the catalog for our Director D bootstrap.yaml file that we just created. There's that. Now we'll pass in a catalog for the dev bootstrap, which is provided by Director D internally, which is actually part of the install process. So we'll go ahead and use it straight out of the virtual environment. Director D share tool bootstrap zmq.yaml. And that's all we need. So we'll go ahead and run that. This is going to take a few minutes. Because we have a stanza in there for the server, it's actually going to go ahead and rerun the server installation and make sure all of the configuration stuff is set up for a cluster. So as this is bootstrapping, it's worth calling out what we're doing. Basically, we're taking Director D that's running on the server now and bootstrapping the 4 nodes inside of our environment to also run Director D. Those 4 nodes are then going to be used to provision our 25 containers, and all of that is actually done using orchestrations that are already provided by Director D. Within Director D, we have the ability to bootstrap large clusters. Basically, what we're trying to do is build a lifecycle manager that allows us to meet the demands of large-scale environments without having to reach for a whole bunch of different tools to do a whole bunch of different things. All right, everything's all bootstrapped, and now we're ready to go. Let's go ahead and check our cluster, make sure that it's online and that our 4 client nodes are responding to the server. All right, so here we go. Everything is installed, everything's bootstrapped, and we're ready to go. So let's go ahead and do a little check to make sure that our nodes are online and that everything is active. Opt, director D, binge list, nodes. Just to do a quick little overview to show you what we have going on, we can actually see that we have director D0 is our server. Then we have director D1, 2, 3, and 4 as our client. Each one has their own independent expire time. We are running the same version of director D, which is the pre-release version of director D 11.1. The host time, we can see, how long it's been online. And then we can actually see how long the agent has been online, as well as the unique machine IDs and the driver that we're actually using. So all of this combined gives us an idea of what our cluster kind of looks like. What we're actually going to do is spin up 100 containers inside of these 4 virtual machines. That'll give us 104 clients that we can do our scale test with. So let's get to provisioning our containers. The very first thing that we need to do is run our Podman install. So let's use the built-in orchestrations inside of director D to install Podman inside of our 4 virtual machines. So let's do that. We're going to install Podman using the built-in orchestration that director D provides. We can take a look at the orchestrate help, which gives us all of the options that are available to us. And then we'll go ahead and just run the orchestration. We see it received our 2 tasks. All right, so now what we can see is that director D has run the 2 orchestrations, and we can see the execution time for those. It took about 80 seconds to install Podman across our 4 virtual machines. Everything was successful, everything was started, and we're good to go. All right, so Podman is installed. So what we're going to do now is provision our 25 containers per host. Now there's a built-in scale test orchestration within director D that will do this for us. We're going to copy that, customize it a little bit, and then execute it. We'll put that in our home directory. Let's go ahead and edit that file. We can see what it does directly. First thing, install Podman. We don't need to do that. We've already done it. Second thing, pull the container from Quay. Third, it's going to tag the container that we pull from Quay as director D. Then it's going to provision 50 containers by default. Well, we only want 25, so let's change that. Then you can see it's going to start it up, and then it's done. Easy peasy. We're going to execute it across our cloud, which is our 4 virtual machines, and in the end, we'll have 104 clients to do our scale test with. So let's go ahead and run that. There's our 3 tasks, just as we have customized inside of our scale test orchestration. All right, so we can see that the pulling of the containers across the 4 nodes took around 12 seconds. Tagging it took 0.2 of a second. And we can see that we have about an execution time of around 16 seconds. So let's go ahead and check our clients now. Again, we dive into our virtual environment, manage, list, nodes. And here we can see I've got a total of 104 items. So now we've got 104 clients on 4 physical pieces of infrastructure that span a switch. So what we're going to do is run the comparative orchestration, which will execute 1,000 individual tasks across all 104 clients. And then we'll go ahead and take a look at the analysis of that execution. So the very first thing that we're going to need to do is to change our directory into the director D source code, which is where the tests are, right? So we're going to go ahead and go into the test directory. So let's go ahead and fire up the comparative orchestration and take a look at it real quick. Here we are. We've got jobs, skip cache, echo hello world. Very simple. Incredibly simple. So all this does is descend into bash and run hello world. And it's going to do it on all 104 of our nodes 1,000 times. So with this, we can actually then begin understanding how long it would take to interact with 104 clients for 1,000 tasks. Now that's important, right? Now, this is a know-nothing command, right? This takes microseconds to execute on a local terminal. But what we're testing is the interaction between director D and the remote client target and the speed at which it can handle all of those different tasks across our 104 clients. 104 clients is a fairly large environment. While that may not be massive hyper scale, we can take the information we get out of these 104 clients and then use math to determine how long something would take in, let's say, 500 nodes, 1,000, 2,000, and then go from there. So let's go ahead and get started. We got our nodes to our orchestration command. Let's uncomment it and run it. Boom! 1,000 jobs against 104 nodes. What will happen? Well, it's gonna run 104,000 jobs. That's what's up. There were minutes. There were many, but not too many. All right, so our orchestration is now complete. We can actually see at this point, every one of the jobs is done. You just keep scrolling. All 104 have checked in, every task executed, and it's complete, which is amazing. That's pretty fantastic. Now, if we take a look at the parent, we can actually see the real runtime of the job was 1,311 seconds. 104,000 things done across 104 nodes, 20 minutes. Not bad. Could it be better? Absolutely. Will it be better? Yeah, it will. We're getting there. But it's already wicked fast. When we analyze the data, we can actually see something that's pretty incredible. While the 104,000 jobs took 1,311 seconds to execute, the combined execution time, 7,000 seconds of execution time. We did 7,000 seconds of work in 1,311 seconds of time. And this is in a linear fashion. So there we are. A scale test of Director D at 104 nodes, running 104,000 jobs. Pretty cool. So that's it. That's the Director D scale demonstration. It's simple. It's easy to understand. And I feel like it hammers home the point that within Director D, we're able to do some pretty awesome things in a really compelling fashion. So yeah, that's that. That's Director D. That's the project update. I hope you have enjoyed this video and it's been informative. I know it's been a little while since we've done an actual standalone video of Director D and some of the things that we're doing with it. There's been a whole bunch of stuff that we've done. In fact, we've done a bunch of different live demonstrations. We've talked about it at a couple different project gatherings and some meetups. We've built out a nice little itty-bitty community on our IRC channel over on the Libra chat. There's been a lot of movement within Director D, and it's pretty exciting. So I hope you can actually jump in, join us, use the project, abuse the project, find out where it sucks, because we want to make it better. We're going to use this tooling to build out the next generation infrastructure for data center management and cloud infrastructure, focusing first on what we can do within Triplo. I've been rambling, I've been talking, but I hope you've enjoyed this video. If you liked it, give it a thumbs up. If you haven't, well, don't. What we've got going on inside of Director D is exciting, and we want you to become part of the community. Whether you're using and abusing the project or you're wanting to contribute to it, let us know. Jump in the chat, jump in the channel, come by, hang out, join us in one of the live streams that we've done talking about the project and how we're making use of it and some of the different changes we've made throughout it. I stream here on YouTube a couple times a week. Join us. It's a lot of fun. So that's going to end this video. That's all I've got today. Please drop a comment, check out the repository, follow us, fork us, join us over on Libra chat, and I hope you have a wonderful day. As always, go forth and be brilliant, and I will see you in the next one.